All right, so this slide is a really good one for review. It sort of does a compare contrast of passive transport versus active transport. So let's use this to review. On the left-hand side, we have passive transport, our different examples here. Remember, for passive transport, the two criteria that must be met is that substances are moving down their concentration gradient, and number two, no energy is going to be expended on the part of the cell to get these substances to move, honestly, because they're moving down their concentration gradient. So in all three of these cases, right, you've got substances that are going to be moving from an area of high concentration on one side of the membrane to an area of low concentration on the other side. Now remember, different kinds of substances need to pass across the membrane. Those that are small and nonpolar or hydrophobic have an easy time getting across that hydrophobic core of the membrane, and they're just going to pass through the membrane using simple diffusion. Done. Other substances that are charged, that are polar, like ions, for example, they're afraid to pass that hydrophobic core of the membrane, and they're not going to pass on their own. So they need some facilitation, right? They need these proteins, transport proteins, channel proteins, carrier proteins, to help give them that safe passageway across the membrane. These substances are still moving down their concentration gradient, so it's still considered diffusion. It's just facilitated diffusion because it requires that safe passageway that's provided by the transport proteins. All right, active transport, the complete opposite. In this case, the two criteria are that substances are moved against their concentration gradient, and this requires energy on the part of the cell. It also will require transport proteins that have the ability to interact with ATP and therefore can pump these ions against their concentration gradient.